So let's start looking at chemical calculations that involve a balanced reaction equation. And again, I'm emphasizing a balanced reaction equation. What is the significance of the coefficients in a balanced reaction equation? Balanced reaction equation give us the molar ratios for all the substances that are involved in that process. So just as in the previous chapter, the subscripts in the chemical formulas of compounds give us a molar ratios of the compound to the elements in that compound. Similarly, now in this case, looking at the same idea but with a broader perspective, the coefficients give us the molar ratios of between substances that are in that entire chemical equation. So basically, let's look at an example. We saw this equation before. Tetraphosphorus dicoxide reacts with water to produce phosphoric acid. Do you think it is balanced at this time? No, it's not balanced at this time. So go ahead, pause the recording for a couple of minutes while you balance this equation first. Please do it on your own. Do not look at the slides. Try and do it on your own. Okay, so if you do balance this reaction equation, hopefully you get the same coefficients as I did. Now, what do these coefficients mean? It means that one molecule of P4O10 will react with 6 molecules of water to make 4 molecules of phosphoric acid. That combination has to exist for this reaction to take place. This is like a recipe that unless you take a 1 molecule of P4O10 and mix it with 6 molecules of water, you will end up with 4 molecules of phosphoric acid. It's like that recipe that we follow when we cook something or bake something. But you might also remember that we don't talk anymore in terms of molecules and atoms when it comes to processes, reactions, because we don't do reactions with molecules and atoms and ions because they are very, very small. Instead, we talk in terms of moles. So another way to look at the coefficients would be to say that mole 1 mole of phosphoric P4O10 will react with 6 moles of water to produce 4 moles of phosphoric acid. So the coefficients in a balanced equation basically give us that molar ratio between the substances involved either as reactants or as products in a chemical equation. In other words, for this particular reaction, the ratio of moles of P4O10 to moles of H2O is 1:6 because of the coefficients in front of those symbols. The ratio between moles of H2O and moles of phosphoric acid is 6:4 because of the coefficients there. Of course, 6:4 can be reduced down to 3:2. That's totally fine. But what I need you to recognize is that the ratio of the moles of substances in a chemical equation is coming from these coefficients. So when it comes to solving some problems such as this, we can therefore use these ratios as conversion factors. For example, let's look at the first one. They're asking us to convert so many moles of water to moles of phosphoric acid in that one equation. And so we are going from moles of H2O, and how many do we have? We have 3.29 times 10 raised to minus 2 moles of H2O, and we need to convert this into, so moles of H2O needs to go to moles of phosphoric acid. It is very important to keep track of substances here. Please don't get lazy about writing the labels down completely, because it really helps in eliminating all confusions when you're dealing with 10 different substances in the same problem. Okay, so that is moles of H2O crosses out, gives us moles of H3PO4. This ratio that relates moles of water to moles of phosphoric acid comes from the coefficients for those two substances. 6 moles of water will produce 4 moles of phosphoric acid. That ratio comes from the coefficients. When you do the calculation, we get 0.0219 3333 moles of phosphoric acid, which should then be rounded to 3 significant figures and therefore gives us 0.0219 moles of H3PO4. So once again, the coefficients in a correctly written and correctly balanced chemical equation give us the molar ratio between all the substances involved in that process. So here's another one. Please go ahead and pause the recording and try and set it up on your own. Okay. So 0.782 moles of water this time have to be converted to, so moles of water goes on the denominator so that we can cross it out. It needs to be converted to moles of P4O10. This ratio, according to the balanced equation, 6 moles of H2O will react with 1 mole of P4O10, which upon calculation gives us 0.1303333 moles of P4O10. Needs to be rounded to 3 significant figures, so that gives us 0.130 moles of P4O10. Okay. Once again, pause the recording while you try to attempt this next one on your own. So 0.06530 moles of phosphoric acid this time need to be converted to moles of P4O10. Crosses out. The ratio between these is 4 moles of phosphoric acid will be produced from 1 mole of P4O10. Upon calculation and writing the answer in 4 significant figures this time, the final answer after rounding is 0.01633 moles of P4O10. So once again, as to remind you that the purpose of the coefficients is to give us the molar ratios between substances involved in the chemical process.